Today, you're going to discover what it takes to go to Mars. Scientists and engineers study every detail to make this mission a reality. But what does it take to cross space and reach the red planet? Mars is 225 million kilometers away, and every step of this journey involves challenges that push the limits of technology and human endurance. It's not just a trip, it's the greatest adventure humanity has ever attempted. Stay until the end. I'll reveal a secret that few people know. Before liftoff, everything must be calculated with precision. The mission to Mars begins long before the rocket is launched. Planning doesn't only involve building a spacecraft, but also preparing the astronauts mentally and physically. They need to undergo intensive training that simulates the extreme conditions of space. It's not just about learning how to operate the ship, but how to survive months of isolation. They will be tested in enclosed, confined environments to ensure that their mental health withstands the pressure of being so far from home. But the journey to Mars doesn't begin with the spacecraft ready to take off. First, it's necessary to develop rockets powerful enough to break Earth's gravity. It's not like boarding an airplane and taking off. The trip requires immense energy to escape our planet's gravitational pull. Every launch must be calculated to ensure that the spacecraft reaches orbit and heads toward Mars without the risk of failures along the way. NASA and other space agencies work tirelessly to improve propulsion technologies, using new materials and fuels that could transform the future of space travel. After liftoff, the challenge doesn't end. In space, there is no atmosphere to protect astronauts from cosmic radiation. The void is vast and full of invisible dangers. Solar radiation, if not blocked, can cause irreparable damage to humans. That's why the spacecraft must be equipped with advanced shielding systems capable of protecting the crew from any threat. Once in space, the ship's speed and trajectory must be constantly monitored. Any calculation error could result in a deviation that delays or even jeopardizes the mission. The trip to Mars takes months, and every day astronauts face new challenges. They must survive in a completely hostile environment. Fuel is another crucial factor. The spacecraft needs to carry enough for the journey there and back, which demands huge amounts of resources. But how can everything necessary to sustain life throughout the journey be transported? The answer lies in technologies that allow astronauts to recycle water and oxygen, making the most of the resources available on board. And when they finally arrive on Mars, the mission is still far from over. Mars doesn't provide the conditions Earth does. There's no breathable air, no water sources, and no ready-to-eat food. Astronauts' adaptation to the Martian environment will be one of the greatest challenges. For this reason, technologies for building self-sustaining habitats are being developed, where astronauts will be able to produce their own oxygen, grow food, and generate energy. In addition, astronauts will have to manage oxygen production and food cultivation. The first mission W, but the big question scientists are trying to answer now is, what happens after landing? What do we need to do to ensure that Mars isn't just a stopover but the first step into a new era for humanity? The answer goes beyond travel and landing technologies. It involves creating a permanent base capable of sustaining a human colony. When the spacecraft finally lands on Mars, the true mission begins. The surface of the red planet with its arid and dusty landscape is nothing like Earth. Gravity is only 38% of Earth's, meaning astronauts will have to adapt to this new physical reality. But the real difficulty starts with creating a safe living environment. There is no fresh food, no liquid water, and the atmosphere is almost entirely carbon dioxide. What seems like a barren wasteland needs to be transformed into a place that can sustain human life. The astronauts' first task will be to set up their habitats, structures that must be heavily shielded against solar radiation and constant dust storms. These storms, which can last for weeks, are capable of covering large areas of the planet with fine toxic dust. Astronauts will need extreme protection to prevent radiation from damaging their bodies and to ensure they can live comfortably and safely inside the habitats. That's why the structures must be built with materials strong enough to withstand dust particle impacts and the extreme Martian temperatures, which can range from negative 125 degrees Celsius at night to up to 20 degrees Celsius during the day. It'll be to install a system capable of converting the carbon dioxide in Mars's atmosphere into oxygen. This is no simple task. It requires advanced technologies like the MOXIE system, designed to perform this conversion and produce enough oxygen for astronauts to breathe during the mission. The problem is that, in the long run, this system must be able to operate sustainably without constant resupply from Earth. Food cultivation is another essential aspect for long-term survival. NASA and other space agencies are developing closed greenhouse systems that allow astronauts to plant and harvest food. These systems are called bioreactors and are designed to function in microgravity environments. They can generate vegetables, fruits, and even some protein sources, helping to ensure a balanced diet for the crew. However, the lack of nutrients in the soil and water scarcity demand creative solutions, such as using local resources or building closed-loop water recycling systems. But survival on the red planet doesn't come down only to food and oxygen. the lack of protection from solar radiation is one of the biggest challenges. Radiation on Mars is intense and continuous due to the absence of a magnetic field and a dense atmosphere. This means astronauts are exposed to much higher doses than on Earth. To mitigate this risk, NASA is studying ways to build underground shelters or even use Mars's own resources, such as ice, to create protective layers. These shelters must be strong enough to withstand radiation, pressure, and dust while providing stable temperatures and suitable living conditions. Another critical issue is communication. Mars is an average of 225 million kilometers from Earth. This means that any radio signal or communication between astronauts and mission control takes 13 to 24 minutes to arrive. This creates a huge challenge. Since Earth teams can't give instructions in real time, every operation must be carefully planned and executed by astronauts without immediate help if something goes wrong. This communication delay is one of the reasons why astronauts must be completely self-sufficient and prepared to handle any unforeseen event. Mars doesn't have renewable energy sources like the constant, intense sunlight we have on Earth. Therefore, the most viable solution is to use solar panels, but they must be more efficient than the ones we use today. Dust storms can blanket the surface for weeks, blocking sunlight. This requires energy systems capable of storing enough power to keep habitats and systems running during these periods. The use of batteries and other forms of energy storage will be fundamental to maintaining operations on Mars. And when it's time to return to Earth, what must be done? The return journey will be even more complex than the trip there. Astronauts will need to build a launch system to escape Mars's gravity and return to orbit where they can be retrieved. This launch system will be responsible for transporting the crew back to the ship that will take them home, but it won't be easy. They'll have to deal with limited resources and Mars's harsh conditions. This return journey must be carefully planned and executed with precision. Mental health also plays a crucial role in the mission. Being on Mars, far from Earth, with delayed communication and no immediate contact with family and friends, can lead to intense psychological isolation. To combat this challenge, astronauts undergo rigorous training and confinement simulations to help them cope with loneliness and stress. Space agencies are developing strategies to keep crew morale high, such as constant communication with Earth and entertainment adapted to the Martian environment. However, the main support will be group cohesion and teamwork. And as astronauts adapt to this new world, the mission goes beyond survival. Scientific exploration is one of the greatest goals. Mars, with its unique features and potential to have supported life in the past, is a rich field of study. Scientists are eager to discover signs of microscopic life that may have existed on the planet millions of years ago. In addition, collected soil and rock samples may offer crucial information about the history of the solar system and how Earth and Mars were formed. In the long run, the mission to Mars is not just a visit, but the first step toward colonizing the red planet. There are plans to build a permanent base where humans can live, work, and study. This base would serve as a platform for future exploration, not only on Mars, but also on other planets and moons in the solar system. Colonizing Mars represents a grand vision for humanity, becoming an interplanetary species. However, for this to happen, decades of research, innovation, and solving immense problems will be required. Now, the secret that few people know, the real challenge of the mission to Mars doesn't lie only in technologies and survival systems. The secret is that, to make Mars colonization a reality, we won't rely solely on advanced technology and local planetary resources. The key to humanity's future on Mars lies in something we are already beginning to master on Earth: the use of artificial intelligence for process automation and even the creation of self-sustaining systems. Imagine intelligent machines that, besides managing the spacecraft, will be able to build shelters, grow food, and even generate energy autonomously long before the human crew arrives. These systems will be able to adapt to any challenge without requiring constant intervention from astronauts, making the mission much more feasible and safe. So, do you think you're ready for the mission to Mars? Leave a comment below sharing your thoughts on this idea of colonization, and don't forget to subscribe to the channel so you don't miss any news about the future of space exploration. What would you do if you had the chance to go to Mars? Comment now, and let's talk about what awaits us among the stars.